Good morning from Santa Cruz. So today we're working on area, volume, and perimeter. So let's start with a pretty straightforward question. And that's going to be on test 1, section 4, number 35. All right, we begin with a right circular cylinder with a height of 8. And it says, a dairy farmer uses a storage silo that's in the shape of a right circular cylinder above. If the volume of the silo is 72 pi cubic yards, and I stop and I write volume is 72 pi. Ideally, you would actually know the volume formula, which is pi r squared h. And we'll have a little mini lesson about volume and area. But you don't need to know these because they actually offer them to you. On the top page or the front page, at the top of each math section, they give you a whole host of geometry formulas and other information. That's good to know. So if you don't know it and you don't feel like memorizing it, then you do have reference. So then you just continue and you can substitute the 72 pi for the volume. And, oh, you can also substitute, just do an extra step instead of crossing out. We have the height. So we know that's 8. Now we're going to solve for the only variable that's left, which is the r, the radius squared. So we can, to get the radius squared by itself, we can just cancel or divide out by 8 pi, and those cancel, and the pi's cancel on this side. So you end up with r squared equals 9. Therefore, r equals 3. Now, I'm just going to put down some fake answers here. Let's see, we've got something like that. Those are our answers. Now, I guess we have to read the question. We never finished. Okay, the last question says, what is the diameter of the base of the cylinder in yards? So, if you notice, the word diameter is underlined. They did it for you. But my friend, that is not good enough. Because they underlined it, you know it's important. You should take your pencil and circle that. So the sucker answer here is radius equals 3, and here it is, right? B. But of course, they want to know the diameter. So you have to multiply that by 2, and you'll get 6, and C is the answer. If you made the mistake and instead of multiplying it by 2, you squared it, you would have gotten 9, and that's your other sucker answer. So be very careful and take yourself through the problem by doing things like circling the key phrases in a problem. Okay, now I'm going to get rid of this. Oh, actually, before I do, let me do my little mini lesson here. So this is area and volume. So area is always kind of the, let's get a different color here, the inside portion of some 2D figure. So we have a circle, and the area is pi r squared. It's good to know that. Now, how you get the volume is the stuff inside a 3D shape, right? So that would be our circular cylinder. The base here is a circle. We just added on the height, right? So the volume is the same thing as the area of that same shape times the height. Okay, now if we do that with a rectangle's area is length times width. And then if we want to make it a 3D picture, it's going to be a rectangular box. And we're going to create volume. And volume, using the same concept, is the same thing as area multiplied by the height. And here we've got this side, and that side. All right, now let's do one more shape, and that would just be the square. where all of our sides are equal, yeah? So we have area. Now, area of a square could also be the same as area of a rectangle, length times width. But it's also really helpful to know that side squared is another way to represent it because all the sides are equal. So length times width is the same thing as side squared. Okay, now if we want to make this 3D, it's a cube, or you might think of it like a die, like rolling the dice, right? And we've got volume is length times width times height. Or if you want to use this side, it's going to be side cubed because we have all of our sides, again, are the same. So you can just cube one of those sides. Okay, that's our mini lesson. Now, let's go to the second question, which is considerably more difficult. This is test 2, section 4, number 30. And I'm going to draw it out kind of small at first and then probably blow it up after so it's a little bit easier to read. So we've got a 6-sided figure and then we've got a square attached to it. Now, it says the figure above shows a regular hexagon, and a regular hexagon means all the sides are equal, and therefore all the angles are equal. With sides of length A, okay, so A and A and A, that's good enough. And the square width also with sides of length A, which makes sense because this is one side of the hexagon, but it's also one side of the square. So every side of the square is also A. If the area of the hexagon is 384 root 3, so area of the hexagon, we write it down, right? We always do that. What is the area of the square? So we're looking for the area of the square. Okay, now this is a regular hexagon, right? So that we can split it up. Well, actually, before I go there, I want to point out something. Whenever you see a root 3, I want you to be thinking of a 30, 60, 90 triangle. Anytime you see a root 3, that's the only reason why it would ever be in a problem. And the sides of a 30, 60, 90 are 1, root 3, and 2. Now, they also give you that in the reference information. But this is something that you'd at least need to know to be cued into, oh, isn't this one of those sides of a special triangle? And then you could go look at the reference information. But no, personally, I prefer that you actually just know it. Okay, so now, having said that, we can just kind of go from vertex to vertex and split this up into a bunch of triangles, right? Because we're looking at this triangle information here, and we want to create a 30, 60, 90 triangle. So now we've got, we want to figure out the area of the square, and so it's going to be this triangle here attached to the square that we're really interested in. So here's where I'm going to blow that picture up, and I'm going to put it right side up so we can really see it much more clearly. And then I'm going to put this square at the bottom. All right, now we know, well, first of all, we want to figure out the, let's see, we've got A and A. Everything is A, right? We know these are A because everything is regular, right? So if every side on the hexagon is equal, then every line is going to be equal, extending from the center to each vertex. Okay, so this is what we've got so far. Now, what we need to do is we need to figure out what A is. Because once we know what A is, we know we're going to be able to figure out the area of this square. And that is, right, that's just all the stuff inside this square. Okay, So we need to know ultimately we need to get the area of the triangle because that's where we have some numbers, right? So the area of the hexagon leads us to the area of the triangle. Now, an area of a triangle, we'll just do the shape here, is 1/2 base times height. Okay, we need to know the height, so we need to drop a little height line here. And then this is going to be a over 2. Does that make sense? That the whole, well, let me make this really clear. This whole thing, the whole big base is a. We just split it in half by dropping the height line. So this from here to here is a over 2. So now we have our 30, 60, 90 triangle. How do you know that? Well, I'll just draw it over here. When you have an equilateral triangle, as we do, right? Every side is A. So this is equilateral. That means that all your angles are 60 degrees. And when you drop a line, you split this angle in half. So that's your 30, 60, 90 triangle. Okay, so now we've got 30, 60, 90. And, well, let me use this color. We know that our hypotenuse, right? This is our hypotenuse, is A. And that is the side opposite the 90 degrees. So I'm just going to put it here. We know that here's your 30-degree angle, and here's your 60. The side opposite the 30 degrees is A over 2, which makes sense because we have a 1-to-2 relationship between the smallest and the largest. So this is A over 2 and A. And then the side opposite the 60-degree angle is going to have the root 3 in it. It's as if we took these sides and multiplied everything by A over 2. Okay, check this out. A over 2 times 1 is A over 2. A over 2 times 2 is just A, right? A over 2 times 2 over 1. These cancel out, you just get A. So A over 2 times root 3 is root 3 over 2A. So that is what the height is. And I think I'm just, well, let's see. Root 3 over 2A. Okay, so now we're going to come back to our what do you call it? Formula for area of a triangle. We've got 1/2. Now we're trying to find the entire triangle, remember. So the base is A. We're not looking at just the small triangle, the half triangle. We're looking at A. And then our height is root 3 over 2A. Yowza. Okay, so we bring it down. We've got 1/2 times root 3 over 2 is root 3 over 4. And we can multiply those A's to get A squared. All right, so that's great. That's where we got there, but we still haven't gotten the A yet. We have to solve for A. So here's where we go back to what they originally gave us up here. We've got this hexagon. The area of the whole thing is 384 root 3. But if we divide it by 6, 384 root 3 divided by 6, we're going to get the area of just this one triangle. All right, and if we do that, it's going to be 64 root 3. That's the area of that triangle. This is also the area of the triangle. So now we have something to actually work with here. Okay, so now we needed something on this side to be able to solve for the A. So now we're going to just, I told you this is a kind of intense problem. We're going to divide this by root 3 over 4. Let me just say, if you don't want to do this problem, it's totally fine. This is the last multiple choice problem in the section. and it's difficult. And you're not required to do this, but if you want to do this problem, and if you're good in math and you feel solid in geometry, this is a doable problem. So 64 root 3. Remember, you can't divide fractions. You have to turn them into multiplication and then flip the last number. So these two are going to cancel out. And 64 times 4 is 256. And that is our answer, letter A. Whew, that is a lot. Okay, I definitely needed the entire screen for that problem. Okay, but now let's take a little break from that. I wanted to show you those two because they're on the test and it's, possible to follow it. So now those are the only two area volume questions on test 1 and 2. So for the rest of the time, I'm just going to give you sample problems. So let's say there's a problem and it says the width of a garden plot is W and the length is 6 feet longer than the width. And there's no picture. So remember, always in geometry, first you draw the picture. So we have a rectangular garden plot. The width is W. And the length, they say, is 6 feet more than the width. All right, now there could be a few different questions. Okay, there could be one question that says, what expression would you use for the perimeter? Okay, so now I always like to label all of the sides. Perimeter means you add up all the sides, right? So you would just do, I'm not going to write them all out. I'm just going to add them up. We've got 4 W's and we've got 2 6's. So the perimeter is going to look like this. Now, if they say what expression expresses the area of a rectangle is length times width, right? Which is going to be W times I don't know why I just wrote a 4, W plus 6. So that's what's going to be. It could also look like W squared plus 6W. Okay, so there you have that. That would be a simple question. All right, let's see. What else might they do? Okay, well, here's one thing that they could do. They could do some kind of an inequality, right? So let's say we'll just stick with this problem, and let's say there was a box. Let's just turn this into a box. We're not going to draw it any differently, but they say the base of the box looks like this, and the height is 50. And they say the perimeter and the height cannot exceed, let's say 120, whatever that is, inches. It doesn't really matter. All right, and then what would that look like? What expression would express that? So again, we determined that the perimeter up here was 4W plus 12. So we're just basically translating. And the height, well, we said the height was 50, cannot exceed. That means it's going to be less than or equal to 120. And then we would just combine like terms, right? So it would be 62, 120. Now they could ask you again to solve for W, in which case that would be fine. You would just take it all the way out like you would normally. 4W is less than or equal to, divide out the 4, and you would get W is less than or equal to 1, there's 1 left, 4, and let's say a half. Okay, so it would be W is less than or equal to 14 and a half. Okay, so the problem with doing this section, and this is really true of all of the math, is that there are so many different things that they could possibly ask, but it's all about you having your basic skills in place. Okay, so I'm going to get rid of this. And there could be, I'm going to go back to a circular cylinder. Okay, so let's say they say there's a can. This is my can. And it contains some, I don't know, what's in a can? Canned corn. And, well, yeah, and there's water. So there's water and there's corn. And it says the base of the can has an area of 75. And it says the height of the can is 10. All right, so right away, now, if they didn't have a picture already, you would draw your picture, you would say your height is 10, and you already know the area formula for a circular cylinder. It's pi r squared, which is the area. Well, okay, let me do it this way. The volume is going to be pi r squared h, right? So we know that volume is the area times h, which is going to be the area is 75, and the h is 10. So the volume is 750. Okay, you get that? So this is a subtlety. I haven't often seen this, but I thought I would just show you, where they're not, instead of giving you the radius or the diameter, they're actually giving you this whole entity, right, which is right here. So good to know. All right, so now let's say they also say there is 110 whatevers of water. Okay, and then they ask how much fruit or how much corn there is in this can. So, well, if there's 110 water, this is the total volume. We get rid of the 110 and we have 640 corn. And so 640 is going to be the answer. Okay, so let's see if there's anything else that is interesting here. I'm just kind of scrolling through my stuff. All right. This is, yeah, actually, here's one. Okay, let's say we're going to do the garden plot. All right, so they say there's a garden plot, and it says the length is 5 feet longer than the width, right? So we're going to do width here, and the length is 5 feet longer than the width. And always you try to use one variable. Okay, and then if it says something about the area, so let's say the area is going to be 104, right? And we know that the area is length times width. So we know that 104 equals W times W plus 5. And then we just distribute that W. So we get 104 equals W squared plus 5W. This is looking very much like a quadratic now, right? So now you want to make it equal to 0. So get everything over to one side. And we end up with this. And then we have to factor, right? So it turns out looking very different from some of the other geometry questions. Now, here's what I do to find, this is kind of a big number that you don't really just know. I think most people will not know all the factors. So I start off 1 and 104. We're trying to get to 5, right? So 2 and 52. What else? 3 is not going to go into it. 4 would go into it twice with 2 left over, 6. Okay, and luckily this is the calculator section, so you can just start. You know it's not going to be 5 because this doesn't end in 0 or 5. Probably 6 is not going to work because usually 6 works if it's divisible by 2 and 3. And then using my calculator, I can see 13 and 8 work, and these are the numbers I want to use because if we take 13 minus 8, we get 5. So when we factor, we get a 13 and an 8. We want the plus 13 and minus 8. So our W is going to be equal to negative 13 and positive 8. Now, we go back to the problem, and let's say the problem is either, well, it's obviously going to be asking us for either the length or the width, right? So this can't be negative. There's no such thing as a negative width. So it has to be 8. So W will be 8, and the length will be 13. And that's it, depending on what they ask you for. Okay, good, good, good. All right, let's see if there's anything else that I want to review with you. Yeah, here's a possibility. Yeah, there's 2 more possibilities. Okay, I'm going to go over 2 more problems, and then we'll be done. One thing might be that we're going to do our circular cylinder again, right? But this time, it could be like there's a cone or something on the top and the bottom. So this is an easy problem. Let's say they ask you for the volume of the whole shape. You can see that in the middle, we've got our volume formula for a circular cylinder, which would be pi r squared h. And then we've got a cone. Now, I do not expect you, in fact, we have 2 cones. I do not expect you to know the volume of a cone. Nobody knows the volume of a cone, right? So that's when you flip over to that reference information at the beginning of section 4, and you look for the cone, and you see its volume equals, it's basically the same thing as this times 1/3. It's 1/3 the volume of the full circular cylinder. And then I would write it down in both places, because if you don't, then you are requiring yourself to remember to take this and then multiply it by 2 at the end to account for the other one. So if you do this and then you figure each element out, you're going to have a bunch of numbers at the end, which then you will add. And then you'll get your final number. That's the way to do it, my friend. That's the way that you will not mess it up. Okay? Because believe me, they will have, one of the answers will be 1 cone. The right answer will be considering the 2 cones, right? So if you just solve for 1 cone, you'll see your answer there and feel like you've gotten it right, but you won't have. Okay, there was one other problem. Right, here it is. Okay, let's see if I can fit it on this page. All right, let's say we have a glass. There we go. We're going to do another circular cylinder here. We've got a glass. And let's say, they probably will say to you that the diameter is 3. And then they may say that the height is 6. And let's say that you pour a bunch of stuff in. Let's say you just pour some water in there until it's full, till it's the full 6 inches. Okay. Now, first of all, as soon as you see a circular cylinder, you should be like, okay, that's a volume question. So volume equals, again, pi r squared h. And we've got pi. Ooh, what's the r? Don't say it's 3. It's 3 divided by 2. The radius is only halvesies, right? So you want the 1.5 squared, and the h is 6. So we keep going with this, and we get pi times 2.25 times 6, and we get 13.5 pi. Okay, so that's the volume of this thing. Now, let's say the question says, you're going to take this and you're going to pour it into this massive container here, right? Another circular container. But this one is 1 gallon, okay? And then they tell you 1 gallon equals 231 cubic inches. So you're going to, you see that whenever they have this, like they'll have it in parentheses, they'll say note. And then they'll say that. You know you're going to have to convert. Okay, so you know you have this volume here of 13.5 pi. And you're putting that content into this huge thing over here that is the same as 231 cubic inches. All right, so, and they want to know, let's see, how many of these glasses can fit into here. So we have this total volume of 231, and if we divide it by the 13.5 pi, then we'll get the number of glasses that can fit into this gallon container. And when we do that, we are going to get a decimal or fraction. It's going to be something like 5.4. Now, the question will probably say something like how many full glasses. Well, we have to get rid of that part because that's not a full glass. And in fact, even if it was 5.9, which you would think, oh, well, I always round up for that. No, you wouldn't, because that's not a full glass either. The answer would be 5. Okay, friend, that's it. That's all I've got for you. Make sure you have, I would know your area formulas, because when you know area, then you actually also know volume, because all you have to do is tack on an H at the end and you're done. Cones and things like that you don't need to know, or spheres, all the really complex shapes, they're hardly on the test at all. And even if they are, it's fine to just refer to that reference information. Okay, have a great day. See you soon.